Hello everyone, my name is Rizky Handayani. I am a student majoring Agrotechnology, Faculty of Agriculture, Slamet Riyadi University. Here, I will present a review of my journal entitled Effect of High Temperature Condition to Rice Growing and Yield. Introduction. Global warming becomes a pressure in food production sustainability because it affected crop growth and development. Research on the impact of high temperatures in Indonesia, especially rice, has not been widely reported, so research on the impact of high temperatures and breeding is still not a priority. However, given the continued rise in temperature, this issue will have a serious impact on agriculture production. The purpose of this study was to obtain information on the effect of high temperature stress on the growth and development phase of rice and to evaluate the genotype for tolerance of high temperature stress. The research was held in two places, in greenhouse and experimental garden Cikawayan IPB Bogor. Meanwhile, pollen fertility observation was held in microtechnique laboratory of the Department of Agronomy and Horticulture IPB. The study was held from August 2016 until February 2017. The research method used was a randomized complete group design. High temperature stress is given by moving plants into the house when they are 60 days after planting until harvest. The varieties used are IPB4S, IPB6R, Mekonga, and Situpatenga. Observations were made on the generative phase of plants in two different environmental conditions. Some of the parameters observed include plant height at harvest, the total number of tillers and productive tillers, flowering age, harvest age, seed filling period, seed filling rate, long panicles, the number of filled grains per panicle, the number of unhulled grains per panicle, total amount of grain per panicle, percentage of filled grain, weight 100 grains, weight of filled grain per plant. The observation data obtained was analyzed with test F, advanced test of PNT test, smallest real difference at 5% level for data showing a noticeable difference between treatments. The average maximum temperature during the day is 37.90 Celsius and 42.12 Celsius, while the average minimum temperature is 22.67 Celsius and 23.32 Celsius, respectively, for temperatures on drying floors, T1, and greenhouses, T2. The temperature of the greenhouse is higher than the temperature on the drying floor. Next, in Table 2, the height of the plant at harvest, the age of anthesis, the age of the harvest, the period of the replenishment, the length of the panicles, and the weight of 100 grains don't differ between the strains planted on the drying floor and the greenhouse. The character of the number of productive saplings is not influenced by the interaction of genotypes and the environment. Mekonga has quite a lot of productive saplings and has the longest seeding period. Situ Patenggang has the highest number of productive saplings among the genotypes tested. Based on STI values, Mekonga is the most tolerant genotype followed by Situ Patenggang, IPB6R, and IPB4S. Higher temperatures lower the fertility of pollen in all observed genotypes. Fertility of pollen is very determining the level of voidness in rice, so that the fertility of pollen can be used as an indication of tolerance to high temperatures in addition to results. Table 4. The total number of sepals per panicle owned by IPB4S and Situ Patenggang is no different in two environments. There has been an increase in the total number of genotypes IPB6R and Mekonga planted greenhouse. All genotypes grown in greenhouse tend to experience a decrease in the amount of grain owned except in the Mekonga genotype. The amount of empty grain per panicle in the genotype planted in the greenhouse tends to decrease, but the decrease is also followed by a decrease in the total amount of grain per panicle. The significant decrease in grain found in the genotype IPB4S, which is planted on the dry floor, amounted 2052.4, reduced to 114.71 when planted in a greenhouse. Table 5. There was a decrease in seed replenishment rate in IPB4S and IPB6R genotypes, respectively. Genotype Mekonga and Situ Patenggang showed unreal difference in the two test environments. The percentage of grain content in mild creeping conditions tends to be the same. Genotype Mekonga increased the percentage of grain content when planted in the greenhouse, which increased by 22.94%. There was a significant decrease in the genotype of IPB4S and IPB6R to the weight of grain content per plant planted in the greenhouse, while the genotypes Mekonga and Situ Patenggang had no real difference in both environments. Conclusion. From the results of the above research, it can be concluded that the higher temperature after the generative phase has an effect on several characters, namely the character of the total number of tailors, the number of filled grains per panicle, the number of empty grains per panicle, the total number of unhulled grains per panicle, the rate of filling seeds, the percentage of filled grains, and the total grain weight of each plant. All genotypes grown in greenhouse experience a decrease in pollen fertility. IPB4S genotype is a sensitive genotype, and Mekonga genotype is a genotype tolerant to high temperature stress. References are taken from J. Surahman et al. 2019. Effect of high temperature condition to rice growing and yield.